Yeah, today we're gonna write and solve exponential function from word problems, okay? There are actually only two, no, there's more than two, but there's two that we're gonna learn today, okay? The two basic ones. The first kind is just basically your, like we call it the base or factor problem. It's when they give you a base or a factor, okay? So I'll call this the base or factor problem, okay? Or factor problems. It could be a growth factor, it could be a decay factor. Okay, the other one is percent problems. Okay, in these problems, okay, the first kind, okay, the base problem, we'll call it the base problem for right now. Y equals a times b to the x power, okay? They'll give you an initial, and you have to identify it, initial value, okay? And then they'll give you something that is multiplied, okay? So they're going to give you a factor, okay? So all you have to do is figure out what those two are, then you can solve your problem. Okay, the percent problem is a little bit different. Okay, what you're going to have to do here, okay, it's going to be the same here. You still y equals, you still have your initial value, okay, but the difference is the b right here, okay? The b is actually going to be a percent, so you're going to either have to add, okay, and this is what is called a percent rate, okay? The rate, which is in percent. This is for growth. Okay, and if it's a decay, you're going to subtract the rate, okay? So instead of using b here, okay, all of this right here is b, okay? We're going to subtract the rate, okay? So growth, we add, decay, we subtract. And we're going to go over these problems in a little bit. Okay. Now, growth by factor problem, okay? Remember our equation is y equals a times b to the x power, okay? The first step is to identify, okay? So first thing we're going to do is identify your a and b, okay? Your initial value and your growth factor. Okay, so a culture of bacteria started with 20 strands of bacteria. Started means that initial value. So my A is going to be 20. Okay, if the bacteria divides, that means it splits up into 2 once every minute. So B is equal to 2. Okay, so my equation is going to be y is equal to 20 times 2 to the x power. Okay, once every minute. How many bacteria would there be in 30 minutes? So I need to know what 30 minutes is. So I'll go y is equal to 20 to the 20th power. Okay, so that's what I'm going to put in my calculator. Okay, 20 times 2 to the 20th power. Okay, 4097150. 409.71520. 409.71520. Okay, so that's going to be my answer. That's how you do that problem, okay? Okay, so now the next problem is a growth or decay, remember? Okay, so step 2 is write equation. And the third part is substitute and solve. Sub and solve. Okay. It's going to be the same for this right here. These three steps are the same. Y is equal to A times 1 plus R. Remember, this is the growth. And if I use subtraction, it's a decay. Okay. The only thing is, remember, R needs to be a decimal, okay? They're going to give it to you in a percent, but you have to change it to a decimal. Okay, the population of deers in Oxford is 2000. In 2000 was 485. The population increased 15% each year. How many deers are there in 2018? So I started in 2000 with 485. So A is equal to 485. The population increased 15%. 15% is equal to 15 over 100, which is equal to 0.15. Okay. So A is 485. Okay, so it increases, right? So I'm going to add 0.15 to the x power. Okay, so that's my equation. Okay, this is a growth. So now, the last part is I substitute and solve. 1 plus 0.15. This is 2018, so that's 18 years later. So 485 parentheses 1 plus 0. Delete. 0.15, close parentheses. Okay, and I want 18 years, so the population would be 6,002. Okay, moving on. We're going to do a couple more examples. Okay, the world's population in 2000 was approximately 6.8 billion. 6.08 billion. The annual rate of increase was about 1.26%. Okay, so again, this is a percent. Okay, and we're going to increase. Okay, find the growth factor. So to get the growth factor, we have to remember the growth factor is what's in the parentheses. Okay, so 1 plus R. Okay, remember R is 1.26 divided by 100. Okay, that's how you change percent to a decimal. So we have 0.0126. Okay, so the growth factor is 1 plus 0.0126. Okay, so that's going to be 1.0126 if you put that in your calculator, or you can just simply add. Okay, suppose the rate of increase continues to be 1.26. Write a function, so we can write y is equal to we're going to write a function. This is the starting, okay, 6.08 times, I'm going to just use this right here. I can use this, or I can use this, but since we're learning it this way, I just want you to use what we are using. 126 to the x power, okay? Okay, so now it's 10 years later, so 6.08, 1 plus 0.0126 to the 10th power. Okay, so 6.08 parentheses 1 plus 0.0126 to the 10th power. Okay, so that's 6.89. So it's equal to 6.89. So remember, we are talking about billions here, so billion. That's a lot of zeros. A computer values at 6,500 depreciate. That means it's going to go down, okay? Okay, at 14.3% per year. Okay, remember, I have to change the percent to a decimal. So I divide by 100. So it's equal to 0.143. Okay, so write a function y equals, this is how much it started with, 6,500, 1 minus 0.143 to the x power. And now we just want 3 years, right? So y equals, that's a very expensive computer, by the way, 6,500. 1 minus 0.14. There's a 3 there. 3 to the, okay. So my expensive started at 6,500. And 1 this time, because it depreciates, I'm going to subtract 0.143. And after 3 years, the value of the computer is $4,091. Still kind of expensive. $4,091.25. Okay, moving on. Oops. Alright, I want you to try these two problems, okay? And we'll supply the answers, alright, in a little bit. Alright, if you did it correctly, this is what you should have had, okay? Because the starting point is 18,000, okay? Going to depreciate 25% per year, so remember 25 over 100 is 0.25 or 0.25. You stick it into the equation, that's all right, and remember it's a depreciate, so it goes down, okay? DE right here means it's sort of like decrease, okay? So you substitute and solve, and you get $4,271.48, okay? Next problem. The investment started at $75,000 and it increased, okay, 12.5%, which is 12.5 over 100, which is equal to 0.125. All right. You write the equation, you substitute, and you solve, and you get your answer.